Hi, Tiffany here again. Over the past couple of weeks, we've talked about ship buoyancy and the buoyancy of a few different animals that call the ocean their home. Specifically, we looked at the animal or object's density and if it would allow them to float. Remember, if something is more dense than water, it's going to sink. If something is less dense, it's going to float. This time, we're going to be focusing on the density of water itself. Did you know that water density isn't always constant or always the same? There are a couple of different factors that can change it. Today, we're going to explore how temperature and salinity, or how salty the water is, affects water density. Let's start with temperature. Did you know heat is a form of energy? It's called thermal energy. When you warm up water, you're adding energy to the matter that makes that water up. When you add energy to the matter, it excites water molecules and they start moving around really fast and they like to spread out. When you remove that thermal energy, when you cool water down, the water molecules start to slow down again and pack more closely together. Remember, density is mass over volume. So if you had the same amount of water or the same mass of water, which one would be more dense, the cold water or the hot water? Hint. Think about the buoyancy demonstration we did in our first challenge video. We made a small boat and a little packet out of the same amount of tinfoil, but only our boat floated. Why? Because it had a larger volume or took up more space, which made it less dense than our tiny packet. We already said that the amount or mass of water is going to be the same, so volume has to be the determining factor when figuring out if warm or cold water is more or less dense. So our hot water, with its excited water molecules that like to spread out and move around really fast, take up slightly more space than cold water with our low energy water molecules that like to move really slow and pack a little closer together. Because that warm water has a slightly larger volume, it has a lower density than cold water. So if we had them both in the same container, the hot water should float on top of the heavier cold water. We're going to do an experiment that you can follow along at home and see if this is actually the case. So here I have two samples of water, one hot and one cold. The hot one comes in at 153 degrees Fahrenheit, and the cold one comes in at 43 degrees. So in theory, we expect our hot water to be less dense because it has those excited particles that are flying around everywhere, taking up more volume than our low energy cold water. In order to demonstrate this, we're going to add food coloring to each of our samples. Oops, had those switched actually. Red's gonna be hot, blue's gonna be cold. And we're gonna stir them together. Just a couple drops of each. Go ahead and mix. So you get that nice red color. The nice blue color. And here comes the tricky part. If you try this at home, please have a parent help you because the hot water is extremely hot and I don't want you to accidentally get burned. But you need to get something that is capable of blocking this jar. So it can be an index card. This is just the middle part of a paper plate that I cut out. Anything that's large enough to fit over the container you have the water in. And we have to hold it there and flip it over and put it on top of this one to see if the lighter hot water floats on top or if it goes down to the bottom. Again, be very careful. Have lots of towels nearby. We're gonna give this a shot and hopefully it doesn't go too badly. Now, it should be mentioned before I flip this over that as you can tell, this one doesn't have quite as much water in it. To make it a better experiment that's more accurate, these both should have the same amount of water, but it turns out hot water on a battleship is kind of scarce, so we're gonna make it work with slightly less water today. If you're not doing this over a sink, like I probably should be, I would suggest having something to help you catch any stray water. So I grabbed this little box. Hopefully it'll be enough. Let's go ahead and give this a shot. Firm grip. Oh, towel's not gonna work. All right, firm grip and over. Make sure it's lined up, and then you just want to pull, ow! You just want to pull it out. As you can see, wasn't the most successful there. Definitely had a little bit of splashing going on, but that is the nature of science, right? Gotta try it and see how it goes. So as you can see, even though there was a little bit of mixing going on, you could tell it's more purple than it was red. Our warmer, lighter water is up in the top half, while our colder blue water is in the bottom. So our warm water is less dense and will float on top, whereas our cold water won't. If you do try this at home and you want to see something really fun, try doing it the opposite way. Have the hot water sitting down and put the cold water on top, and you'll get to watch as the colors mix as the dense colder water falls down towards the bottom. Like I said, very messy. Please have parental supervision if you try this at home. But it is a fun experiment, just a little bit of a messy one. Next, let's look at the salinity or the saltiness of the water. Have you ever noticed that when you pour salt into water, it disappears? That's because it dissolves. It actually adds its own mass to the matter that makes up the water. So if we had two samples of water, one salty and one fresh, which one would you think would be more dense? In this case, we're not changing the volume because the temperatures are exactly the same. So mass has to be the deciding factor when it comes to determining if saltwater or freshwater is more or less dense. According to our density formula, our saltwater with its increased mass should be the denser of the two. So in theory, if we had a sample of saltwater and a sample of freshwater, the less dense freshwater should float on top of the more dense saltwater. Your STEM challenge for this week is going to complete an experiment that I'm going to start on this video today to see if you can make a colorful rainbow out of water consisting of different amounts of salt. To do this experiment, you'll need salt, of course, you'll need water, 3 cups, and some food coloring. As you can see, we have our 3 cups here. They each have the same amount of water in them, but this one is going to be our freshwater sample with no salt added to it. This one is going to have 2 tablespoons of salt added to it, and this one is going to have 4 tablespoons of salt added to it. I don't have an actual measuring spoon with me today, so I'm going to make it relative tablespoons and do it with this little spoon I brought from home. And you just want to mix up your 2 salt samples until they fully dissolve. Once your salt's fully dissolved, we get to add some food coloring. I'm going to make my freshwater blue, my 2 tablespoons yellow, and my 4 tablespoons red. Alright, to add your food coloring, just add 1 or 2 drops. And then again, give them a little bit of a stir, just to make sure the color's fully mixed in and the salt's fully mixed in. Now that we've prepared our samples of water, it's time to see if we can stack them based on density to get a rainbow. Before completing this project, let's make a hypothesis. What pattern of colors do we expect to see? We know that saltwater is dense, but does 4 tablespoons make it more dense than 2 tablespoons? Which number is larger? I think our 4 tablespoons is going to be the most dense because it has the most amount of salt in it and therefore be at the bottom of our rainbow. I think our yellow color with only 2 tablespoons is going to be our mid-level, and I think our fresh water with no salt in it at all is going to be the least dense and float on top. So the pattern I hypothesize we'll see is going to be red, yellow, and blue. So when you go to stack your water, you don't want to just pick up your cup and dump it into another cup. That'll make it mix. You need to do it really gently. So what you need to do is get your small container, whether it be a test tube or a little baby food jar or a small glass cup, and something that can transfer the water real gently, like an eyedropper or a turkey baster, or if you happen to have one of these pipettes at home, something that can suck up just a little bit of water at a time that you can gently place into the next container. So I'm gonna have a pipette here today. I'm gonna go ahead and take a sample of the 4 tablespoon water, and I'm just gonna pour that right in the bottom here. All right, so that's the first layer of, makes such a sound. That's the first layer of our rainbow. Second, I'm gonna take my tube, and I'm gonna gently add it to the red. See if we notice any separation of color. See how slow I'm going? Gotta do it real gently, otherwise it's gonna mix and you won't be able to tell. So very slow. Look at that, there's actually a difference in layers. You can see that the 4 tablespoon red is sitting on the bottom and the lighter 2 tablespoon yellow is sitting on the top. Next, we're gonna add our fresh water. Your challenge this week is to see if you can complete this experiment at home. If you don't have any food coloring at home, you can always repeat the experiment that we did in week 1 of buoyancy. Build your little boat out of tinfoil and see how much weight it can hold in the form of pennies. However, instead of just testing it in fresh water this time, let's test it in 2 different samples of water. See how many pennies your boat can hold in fresh water, and see how many pennies your boat can hold in salt water. There might be a difference. Please email us or share your results in the comments here. We hope you have fun playing with your colorful water. And until next time, have a good one. Bye.